Hello, everybody. I'm Ryan. I lead the engineering function here at DoorDash. I've been here for about 3 years and I'm really proud of the team and what they've accomplished in those 3 years, but actually more proud of what we're going to accomplish in the future. 10 of my colleagues here today or more to present various parts of what we do, why we do it, how we do it. And they're all presenting on top of blog posts that they've already written as part of our corporate outreach and sharing, sort of the wealth of information that we have here. Quickly on DoorDash, if you're not familiar, we are a logistics company at our core, focusing on food delivery for the first part of our arc, but now getting into way more. We want to be the logistics provider for everything that services your local economy. So that we're at an inflection point actually currently as we move into other verticals. Convenience and grocery is one of the big ones that we're focused on today. Again, with the goal being becoming the app for everything. Anything in a city, any local entrepreneur could be serviced in a fashion that allows them to distribute their wares, their goods, whatever it may be, to consumers like you or me that want it. And in the process, helping them achieve their financial goals and serving a lot of that with dashers who are also local. So the difference between us and potentially a company that you're familiar with like Amazon is a lot of the revenue stays local. In order to do that, there's a ton of hard problems that we have to solve, let alone like logistics problems, supply, demand matching, all that kind of stuff, figuring out how to price things on the fly, consumer problems, consumer growth issues, working on feed, stack, ranking, all that kind of stuff, working on matching problems. We also have other business lines that we have to focus on. We have an ads engine. We're all over the place. And that's good if you're here late in your career or early in your career. There's plenty to learn of, learn about, and learn from. So the team, I don't want to spend too much of that time on them, but just know that this is a place where we're currently working on the developer platform side of things so that you can do the best work of your career. And if you're interested in any of that, then please join us. Without further ado, I'm going to pass it over to our MC, Justin Lee, who's going to tell you a little bit about the organization, and then we'll get to the talks. Thank you again for attending and spending your lunch hour with us. Justin.
Thanks so much, Ryan. Hi, my name is Justin Lee. I have been here at DoorDash about 3 years. I'm an engineering manager here with a team called Logistics Platform. What I'm going to do here is give a quick overview of, roughly speaking, the different kinds of backend engineering teams we have here and different roles. As you can see in this first slide here, we've sort of broken it up. The kind of most common DoorDash transaction involves three parties, a buyer, a seller, and a driver. We tend to call those consumers, merchants, and dashers here at DoorDash. And a lot of our our engineering functions are broken down into consumer-oriented functions, merchant, and for drivers, we call that part of the team logistics. Kind of along the horizontal band here, I've kind of broken this down into product teams at the top, in the middle, platform teams, and at the bottom, infra teams. Product teams tend to be feature oriented. They have a product manager and often are closely tied into business functions to look at new features and hone existing features. In the middle are platform teams, and platform teams tend to focus on scalability, reliability, and reusability of the team, but we're focused still on the verticals. And then at the bottom are our infra folks who provide generic compute resources, such as they run the Kubernetes clusters, they work on databases and database storage, Kafka queues, things of that nature. My team is a logistics platform, as I mentioned before, so we're right there at the intersection of those two things. So we support a lot of the product teams, and we rely a lot on the infra teams. I'll just show you a few examples of some of the things that different folks have been working on. So I've got an example of products. So you may have seen Double Dash, which is a feature we have where you can tack something on from a different store when you've ordered. We've got that's sort of a consumer-oriented feature. We've got a self-serve menu editor. So keeping menus up to date is a super important thing for the merchants, and we try to make that as seamless as possible. Curbside pickup is something that allows dashers to change the way they pick up the food and make that faster and more efficient. On the platform side, you'll probably hear a little bit about this, but we've been moving from a monolith architecture to a microservices architecture. One of our things we're working on is service regionalization. We call that supercell here, and that's allowing us to deploy a full stack of software in a regionally isolated way. So that if something goes wrong in one area, not all areas are affected. We work a lot on alternative databases. Cockroach DB is my team uses a lot, but others use Cassandra a lot here. From infra, they're working on like client-side traffic routing. Their portable compute workloads is a big project that we're working on, so that if Amazon has a problem somewhere, we'll be able to move things over and not be affected. And we do a lot with tooling such as metrics and logging, things like that. That's just a really quick overview. And I should mention here that, of course, we're hiring. We hire at pretty much every level, from new grads all the way to the most senior people. And we hire at all those functions I just mentioned. I don't know of a single team that isn't hiring right now. And of course, I only mentioned some of the functions of this company. We have teams that do machine learning and fraud and all kinds of other functions as well. But I just wanted to give you a quick overview of that. Okay, so I want to give an overview of today's agenda. We've done our intro. Our first talk here is going to be by Matt. He's going to talk about moving from Python to Kotlin here. And then we're going to hear from Ben, Ashwin, Shannon, and Steve. After those talks, we'll have a panel discussion, and at the end we'll have Q&A. I do want to say that you should open the chat. We have a few announcements that will be coming in through there, and I can see some people have already started using the Q&A feature. We'll try and answer some of those in the Q&A feature itself, and then at the end we'll have some opportunity to do live Q&A. So that's enough from me. I'm going to pass it off to Matt.
Hello, everyone. My name is Matt, and I'm here to talk about us moving from Python to Kotlin for our backend services. I'm a performance engineer here, part of the platform and infrastructure orgs, and let's get started. So first, we're going to talk about how do we find the right stack for DoorDash. To start with, we wanted to talk about why we chose to focus on just one language going forward. The main things are we want to help our teams focus on sharing and developing best practices across the entirety of our engineering org. We also wanted to limit the amount of libraries we'd have to build by having just one language. When we have to build a library once, that makes it easier for teams to adopt and us to maintain our best practices in code rather than being like things we have to copy paste around. And it also allows engineers to change teams with minimal friction because they should be working in a code base that should be easy for them to get ramped up in very quickly if everything's in the same language. Some important features we looked for when choosing the language that we wanted to move forward with. We wanted something that'd be CPU efficient and scalable to multiple cores. We wanted a system that'd be very easy for us to monitor. Obviously, as we're scaling up, as we grow, we want to know how our systems are behaving. And so a system that's easy to monitor makes it easy for us to understand what's going on and how well it's performing. We wanted a system with a strong library ecosystem. At DoorDash, we want to focus on solving the business problems rather than having to spend a lot of time kind of rewriting things that may be standards or have standard libraries for databases or things like that in other languages. We also wanted a language that had good developer productivity, something that developers could easily make progress in and not have to spend a lot of time working through kind of the basics of the language in order to actually, like I said, focus on their business problems. We wanted a language that would be able to scale well and be reliable at scale, and a language that would be kind of future-proof, that was considering continuing investment, and that we felt confident that 5 years down the line we weren't going to have to regret making this choice. The main competition. So these are the primary languages that we were looking between as we were trying to decide where we go next from our old Python monolith. There was Kotlin, Java, Golang, Rust, and Python 3. Those were the primary languages we were focused on. Obviously, there's a lot of languages out there, and they're all very good. They all have the things that they're very good at. But for us, we had to obviously limit the scope. And so these were the 5 that we focused on. So starting with some Kotlin and some of the pros and cons of Kotlin. The one is the strong library ecosystem, and to go along with this is that it inherits all of the Java ecosystem, right? Any of your big Java languages you can use out there, Netty, JDBI, Spring, all these things can be used in Kotlin, which is obviously great because there's a lot of common use cases and common things out there already written for Java. First class support for a lot of the technologies that we use, gRPC, HTTP, Kafka, Cassandra, SQL. Like I said, we wanted things that had a lot of the stuff that were, battle tested that we could easily use in our systems. Kotlin is fast and scalable. It has native concurrency primitives, which is great. Big thing, like I said, is we want to, as we're scaling up, we have to run our systems on multiple cores. And so we want something that's going to be that's allow our developers to easily take advantage of those multiple cores without them having to write a ton of extra code. Kotlin eases some of Java's verbosity. It gets rid of a lot of those patterns and shortens a lot of the standard ways that you have to write code, or that people tend to write code in Java. In Kotlin, a lot of that's not necessary. So we can write much less code, and it's a lot easier to read and kind of understand what's going on. Another advantage that Kotlin has is that it has the ability to use Java agents, which, as we'll talk about later, can be extremely powerful. Some cons of Kotlin at the time, right? This was a little over 2 years ago now. It wasn't as common on the server side. And the other thing is that concurrency isn't as trivial as some languages like Golang or Python 3, where it's very easy to write those kind of concurrency premises. In Kotlin, there's a little bit of that you have to do, and you have to understand kind of how it works a little bit more than you do in those languages. The other big competitor was Golang. Go obviously has again a huge library ecosystem and first class support for all of the technologies that we use. Again, it's fast and scalable. It also has great concurrency primitives, like I said, even better than kind of what you get with Kotlin. And the other thing was that it's extremely common on the server side, right? Like Go primarily lives on the server side, so there's a lot of wealth and a lot of knowledge that we can pull from, kind of just in the common web and in the open source ecosystem to understand. The negatives of Go is that the data modeling can be a little bit harder for engineers that are unfamiliar with the language. It doesn't follow the standard object-oriented kind of way of thinking about how you set up your objects. You have more of the what's called duck typing. And at the time, there was no generics, right? Or I guess there still isn't. That's coming in the next release. But that meant that like certain classes of libraries that we tried to develop kind of best cases for would be a little bit harder to write code for. The last one that we're going to do kind of a bigger deep dive on is Rust. The benefits of Rust are that it is extremely fast. And on top of that, it has no garbage collection, which eliminates like a whole class of issues that people generally have to pay attention to when using Go, Java, Kotlin, Python, things like that, right? There's no garbage collection. Rust also has had a ton of, kind of investment from both large companies and large open source projects. So there is a very exciting language, one that has a lot of kind of, backing behind it. And it also has an extremely complex and powerful type system. The negatives were, again, this was a couple of years ago, so Rust was still relatively new and hadn't quite had a lot of the advancements that it's gotten in the last few years. But it also meant that there was like less of a library ecosystem we could pull from. And on top of that, the memory model with Rust can be a little bit harder to learning how to deal with the borrow checker and things like that. So in the end, what do we choose? We choose Kotlin. Why Kotlin? One is the simpler data model for engineers over Go and Rust. A lot of times, engineers have trouble figuring out how do I express this concept or this business operation that I'm trying to do. Kotlin is a little bit easier to deal with than those. It has simpler concurrency over Java, right? A lot of that, easing the verbosity, making it easier to do multi-threaded, deal with callbacks and things like that. That was a big reason of why we went with Kotlin over plain Java. It's faster and easier to take advantage of multiple cores over Python 3. And like I said, the Java agents are super powerful. For example, we rolled out OpenTelemetry, distributed tracing across our entire fleet with no code changes from the service teams. Like most of them didn't really even know that we were kind of doing it. We were able to just kind of like transparently make it happen. And then we can announce, hey, everyone, you have access to this new tool, or you can see distributed tracing across your entire system. And the last thing is that we really kind of do enjoy some of the functional programming paradigms that you get with Kotlin over, like I said, languages like Java or Go. It's kind of, it takes a little bit to get used to it, but once you get used to it, you can kind of write more compact code that's, like I said, it's easier to read and easier to understand. What went well? A big thing is that, Kotlin brings in a lot of safety around nulls that you have over Java, right? So you can define, your functions as not taking nulls. And even when you do take nulls, it comes with null coalescing operators that make it real easy to safely access the parameters versus, those big if chains where like, if this is not null, then if this dot this is not null. You don't have to do any of that in Kotlin. It's much easier. Coroutines eliminate the kind of the callback hell that you kind of get into with languages like Java, where you have to add like all this future dot add callback. No, you can call await. You can do await all in a group of futures and things like that, and better handle doing multiple things at the same time. Annotation processors, we've started investing in these a little bit, and it makes it easier to have kind of code that generates code. And the reason why that can be powerful is, as we've adopted things like Prometheus and Open Metrics, the libraries can be like a little bit harder to use, just the plain libraries where you have to remember like the order and the number of labels on your metric and things like that. But with an annotation processor, right, we can annotate the metric and then generate code that creates a function signature that does it right every time. And then you can see that in your code completion and see that, when you compile it, that you have the right number of arguments. And that helps us, catch things at compile time in CI/CD versus things that may end up happening at runtime if we didn't have those features. And lastly, the coding style isn't that different from Python or Ruby, which a lot of our developers had extensive experience with. Which is why, it made it a little bit easier for us to transition people over. What's going on with our Kotlin stack now? So we focused on, obviously after we adopted Kotlin, now, we originally just kind of let people kind of build however they wanted to in Kotlin. So we have a variety of systems in our backend from, Spring, Micronaut, and these other ones. And now going forward, we've built a common framework that we're using for all new services, and we've begun migrating some of the existing services. We call that framework Asgard. And it's sort of, it's all of our best practices rolled into one, and it eliminates like a lot of the copy pasting that you used to see in other situations. It supports gRPC, HTTP, Kafka, the Cadence workflow engine, and much more right out of the box. We've written a custom Gradle plugin that again reduces the amount of code people have to write to onboard onto our custom artifactories, our versions of code coverage. All that stuff comes right out of the box. As soon as you install this plugin, you don't have to go and copy all those lines over yourself. It's pre-wired with like I said, our distributed tracing, our open metrics, structured logging, load shedding, circuit breaking, surface authentication. All these things you kind of get with by flipping a few flags in a YAML file versus having to copy over a bunch of code. We've also introduced customized wrappers for a lot of our common data stores to make it easier to use them in the correct way and with the correct settings so that you can handle node failovers and other things right out of the box without having to remember, oh, do I have to put these lines, which config flag do I set so that it refreshes the node topology? Don't have to do that, it's automatically set for you. Where are we going from here? We have a lot of enhancements that we're looking forward to as we continue to expand on this platform and make it even better. We're looking at upgrading all of our services to Java 17. We've started doing this for a few of them, and we've seen amazing enhancements. Just coming from, even if you're just changing the runtime from Java 11 to Java 17, we've seen lower CPU, lower memory, better garbage collection performance with some of the new garbage collection engines like Shenandoah. So we're really excited to continue to roll this out and onboard all of our teams onto Java 17. We've also started doing auto tuning of the JVM, right? You can, we run in Kubernetes, and as your pod comes up, right, we can look at how much resources your pod has been assigned, and we can auto tune a bunch of the JVM options for you, right? We can pre-allocate the memory, we can set the number of threads the garbage collector uses, and all these other things to automatically happen for you without you having to remember, oh, I have to go change my XMS and XMX every single time I change how much memory my pod has and things like that. We can figure out a lot of that stuff automatically, and that way you don't have to do it yourself. We're going to be rolling out continuous profiling. This is going to be, a nice win, particularly for understanding kind of like incidents, like, oh, why during this incident was my CPU high, right? With continuous profiling, you don't have to remember to go grab a CPU profile when you're in the middle of trying to resolve an incident. You'll always have it. And you'll also have historical things to compare it to. It's not a thing that you have to remember, oh, someone needs to go grab a profile with YourKit or JFR or something like that, right? We'll have it always, and we'll have it there so that you can understand how is my system behaving. We're investigating migrating to ARM-based instances, or at least part of our fleet. Being on the JVM, a lot of this should be basically trivial for us to adopt. We're not running compiled code like Go or Rust where we'd have to recompile it to work well on an ARM instance. We can, for the most part, just take the Docker image and it'll just run, and much more. So we're excited to continue to invest in our Kotlin platform and collaborate with the open source community. And moving forward, I believe we have Ben, who's going to be up next.
Great, thanks so much. Hey everyone, my name is Ben Katz. I lead some engineering efforts on the Drive team here at DoorDash, and today I'm going to talk to you about route optimization. So the first question you might have is, why would you want to optimize a route? And the answer to that, like many things, is because of efficiency and customer experience reasons. So specifically in this area, if we don't correctly optimize the route, we could experience some issues in different areas. So particularly on the merchant side of things, if we generate a suboptimal route, we may assign too many different dashers to the order, which overloads store operations. And then on the dasher side, they'll experience long wait times. Then on the customer side, they might get their goods late. So there's sort of a network effect here where not optimizing the route can cause several of these problems to happen. And then the next question you might have is, how do you optimize a route? And the answer is, it sort of depends. So today I'm going to be talking through how we optimize the large routes for the Drive use case, and how we did that throughout DoorDash's history so far. So in 2018 to 2019, we had a very small number of merchants requesting extra Valentine's Day or other holiday retail deliveries, for example, but the DoorDash system only supported up to a couple of orders per dasher. So this wasn't good enough for these orders. So our solution involved building a sort of a manual CSV uploader, having an API to receive the CSV, and then going ahead and synchronously creating the deliveries and handling assignment. So this is basically what it looks like. I won't spend too much time on this diagram. Basically, there's an API, there's a CSV that gets uploaded, and then we call one of our legacy APIs that was written in Python at the time to go ahead and create the delivery, assign that to the Dasher, and the Dasher app receives it. So the operations team would actually define which deliveries were there and which Dashers we should assign those to. Now, COVID-19 changed a lot of things for DoorDash, as it did many companies and the world at large. So for us in particular, we had several inbounds from large organizations like United Way, nonprofits, public school systems asking for help delivering a very large number of prepackaged goods for COVID relief. So we had to improve our existing system. So what we did is we improved that CSV uploader to now use block storage to handle larger file sizes, and then use multi-threading to create a bunch of deliveries in parallel, as well as a third party to help us with route optimization, given the time constraints. So this is depicted here. We're using S3 for block storage, and then we end up calling our legacy APIs again at this point in parallel, and then calling out to a third party for route optimization. Moving on to the present, we had more demand, even so, from further large-scale retailers. Think of like Walmart, Macy's, basically giant retail chains that needed help delivering an exceptionally large number of orders on holidays, but also just normally. And on the right, you can actually see the first route that we generated based off of our new system that was able to handle this, which I'm about to talk about, which is based on an in-house algorithm and occurred after our migration to JVM. So in this case, what we ended up doing is most of our system had been moved over to Kotlin at this point. So we had a new Drive API built in Kotlin, which performed better. And the merchant's able to call our API. We then submit the messages over the queue, and then we process those messages in terms of processing for route optimization within our assignment system called DeepRed. Now, what did this result in? Basically, we got extremely low cost from using our own algorithm. The third party we were using previously charged us per API call. That doesn't scale to hundreds of thousands of deliveries. And then we got better latency, better integration with the DoorDash system. Some of the cons would be, this does experience some timeouts, although we do have a fallback. And then it, of course, doesn't scale to support our future vision, which I'll talk about later. So you might be asking, where's the code? And I'll show that to you. I'll do sort of an abbreviated version so that we stay on time. So this is very similar to what our code looks like inside of one of the deep red nodes that's handling route optimization. So we're using Scala futures to help us to asynchronously process these different optimization calls. And the line highlighted in yellow is where we actually run the optimization algorithm, which I'll describe next. So to actually optimize the route, we found an interesting research paper, which we based this on, which is called, the approach is called Brew and Recreate. So the high level overview of this is that we get our input as a list of jobs to optimize, which is what the previous code was depicting, which is basically where we have a list of candidate drivers and deliveries that they can handle. Then we use a randomness factor to generate an initial solution, which is likely not optimal. Then we determine which parts of the randomized solution are able to fulfill the constraints necessary for the problem, in this case, delivering on time. And so now we have a list of unserved and served jobs. The served ones are the ones we can handle. And then in the recreate step, we try optimally inserting the items that could not be handled into the list of served jobs. And then we have a combined solution that can be handled. And this combined solution gets generated and scored based off of a number of factors. And if it exceeds the quality of previous solutions, it's now considered the best solution. And we sort of repeat this process until we've exhausted like a time limit or a number of iterations. So what is the future of route optimization? A few things here. We want to allow merchants to upload themselves instead of operations doing the CSV upload. And we've actually just done this already. The second thing would be scaling beyond, let's say, 10s, 20s of orders to a dasher to hundreds or even thousands in the future. And to do this, we need to support extra large vehicles like trucks, vans, things like this, to be able to handle some of these larger items and larger numbers of orders. Great, that's all I had. I'll hand it over to Ashwin.
Thank you, Ben. Hello, everyone. I'm Ashwin. I've been at DoorDash for about 5 years. I work on this team called the Kotlin platform team. As you already know, most of our backend code is written in Kotlin. And I'm going to talk about a project that I worked on when I was working for the consumer platform team. So we're talking about how to improve development velocity using like generic UI components that are server driven. Let me talk first about what our APIs looked like many years ago. This is like, and over here you can see what the DoorDash homepage looks like, and I'm going to tell you how each part of it is composed. In a traditional resource-based API fashion, you can see that each of these different components on the homepage is built using a different API. They all have a different response structure, and anytime you do need to make a change to the homepage, you will most likely need to change the API and also change the front end, which can take a while. Next slide, please. So the problems here are, one, with mobile releases, they can be a little time consuming because they need an application store approval, and you do tend to have a gradual ramp over a few weeks. And even then, most consumers may not even update their applications. The second thing is that when you're leaving some amount of business logic to different clients as essentially a re-implementation of the same thing across different platforms, which is needed because how all the individual APIs are pieced together is still left to the clients. It inevitably over time leads to more and more divergence. So that's something that we would just like to avoid. Right. So coming from these problems, these were the design principles that we settled on. We wanted to, and then this is based also on one of our previous blog posts related to or introducing a concept that we call display modules. So we wanted to decouple backend responses from data models and instead focus on client-side view models. We wanted to remove as much business logic on the client code as possible. And we wanted to share UI components across product surfaces, reducing incremental effort whenever we wanted to launch a new feature that was just reusing something that was already written. Next slide. Right. So based on these principles, we decided to, or we came up with this building block called a facet. It was made up of very primitive elements of the view, like text, images, events. By events, I mean like a click or any other sort of action, some logging or analytics data for clicks and impressions or anything else of that sort, some information about what type of component it is so that each client can understand how to render it and how it should behave. And of course, like this building block can be nested. So you could have like a more structured sort of set. You could compose these together in a nested format to come up with more complex interactions. For the most part, we did not focus as much on style. We wanted to get the concept out there and then add style on incrementally and gradually to control the amount of complexity that we're introducing. So on the right side of the screen, what you see is like a simple API response that's constructed from this. And this is actually the API response that we use to develop multiple APIs, all of them having the same response. And on the next screen, you will see the views that we actually built using this. So this was the minimum viable product that we wanted to test out our concept with. So we are trying to build these collections with the tiles, as you can see on the left screenshot, and some of these rich landing pages that you can see on the middle and the right screenshots. Right, so we launched this. It was a success. And then we started thinking about how to go from our V0 to our V1. And that involved adapting this framework to support the homepage, offers page, and we're also trying to expand more into other verticals outside of restaurants. So this was also really a story of how we can support multiple home pages for groceries or convenience. The major changes that we needed to work on were more work on animations and interactions, paging, and also the ability to reload specific sections, as in the case of some of the filters that you see on the homepage. So we wanted to not touch the rest of the homepage, just like designate a specific section. Right. Next slide, please. All right. So anyway, like we did roll this out to our homepage and all of those other pages. I just wanted to take a moment to talk about learnings and results from our project. So the first one was about like versioning. We did need to think about like maintaining backwards compatibility whenever like new components or actions are added, because older versions of your application will not know about the new behavior, and in certain cases that can break. But having a versioning system in place can help you not send something back to an older version of an app. We did make a trade-off about like some heavy UI and state maintenance. For us, something such as filters, like making them like completely server-driven can be a little complex. So that's something that we deferred into the future. And the third thing was about like convenience fields. We did have some flexible fields, and a lot of developers tended to gravitate towards it because it's easy to think of that since coming from a resource-based API world. But we're trying to minimize our usage and track the existing usage of those. Lastly, we were able to come up at the end of this project with a very rich component library of reusable components. We were able to expand to a lot of new use cases and verticals, groceries, convenience, gifting, and many more. And we were able to improve development experience and velocity by a lot. In most cases, unless you were adding a new component, the level of effort got reduced to just a backend change. All right, that's all from me. Thank you so much. And next up is Shannon, who's going to talk about detecting infrastructure failures. Thank you.
Thank you, Ashwin. Hi, everyone. My name is Shannon Lee. I'm a software engineer in the core infrastructure observability team at DoorDash, and I've been working here for almost 3 years. So today I'm going to talk about how we improve our observability strategy to detect infrastructure failures more quickly and reliably. Let's first take a look at the original monitoring strategy at DoorDash. So DoorDash's microservice architecture consists of multiple loosely coupled and collaborating services managed by our product service team. And they own the service level metrics like error rates, response latency, and receive alerts when the performance degrades. In addition to this, we also have a set of infra components maintained by the infrastructure teams. Each of them have the system level metrics measuring its own performance, like CPU and memory usage. Although these two types of monitoring are essential, there are still some deficiencies. Since one service may depend on multiple infra components and one component may also be shared across different services. In this case, when one infra cluster is down, it may result in cascading failures and fire multiple alerts together. For example, if an unexpected failover happened with one cache cluster, all services rely on this cache may get paged for higher response latency and error rates. At the same time, the infra team may also get higher I/O rates and CPU usage of the associated database and see more messages get queued in the queuing system. In this case, all these alerts with different ownerships, they are firing together, which makes engineers very hard to identify the root cause, unless someone manually checks the status and events of that cluster. So due to these deficiencies, we found it crucial to have an additional monitoring approach that could provide fast and reliable signal to identify the infrastructure health directly. To accomplish this, we developed InfraProber, which is a new tool that uses active probing to detect InfraProber failures. Here are some key points. We believe that the health and the reliability of a system is best measured from external users' point of view, which can be established by black box probing. To achieve this, InfraProber runs active probes on our infra components by executing the smallest and simplest checks that can mimic the basic client behaviors. Also, to have reliable signals to measuring the system uptime, InfraProber focuses on the success and failures of the probe execution results, rather than any issues inside the probe operation steps. Let's go back to this example again. To monitor the caching system, InfraProber keeps running set and get checks to each of the cache cluster. If one of them is not accessible, InfraProber can detect the failures immediately and fire off clear alerts ahead of all other alerts. So based on the alerts timeline, the root cause becomes much easier to detect. All right, let's see how we implement InfraProber. Here are some key components. We define different types of probes like Postgres, Redis, Kafka probes, and each of them execute a time-bound check against the component. We use CloudProber, which is an open source tool, as our probe manager. It does an excellent job scheduling and running probes and exports results as a set of Prometheus metrics. We build an infra collector to pull the latest states of our components from the cloud and generate configuration files, which will be used to manage probes. So we also have a dynamic allow list and a block list to enable or disable probe easily, and have a cleanup job for garbage collection purpose. When we are building InfraProber, here are some key challenges we've resolved. First, how to design reasonable workflow for each probe. As we mentioned, we designed the workflow based on the client-side behaviors. We made sure each of them are small and simple enough to avoid extra noise from any complicated probe operation steps. Next, how to make the alert sensitive enough to detect issue quickly while also maintain a high signal-to-noise ratio. Here, we conducted multiple experiments to find the best probe intervals, timeouts, and alert thresholds for different types of infra components. We also automatically create some alerts maintenance windows to eliminate the potential noise during the InfraProbe server warm-up stage. We also separated the InfraProbe internal alerts and the actual infra failures alerts. For example, if the probe manager failed to schedule probe, that shouldn't be counted as an infra failure. The other challenge is to limit the system resources overhead. To keep the resource usage low, we made the probe executions to be as lightweight as possible. And since probes need to be run repeatedly, for the ones with higher frequency, we use server mode to hold long connections to avoid creating too many new connections to the cluster. Also, we took the time to live into consideration when persisting data in the probe workflow. All right, currently, InfraProber covers 10 infra components with more than 250 probes and running over 1.2 million executions per day. It can detect infra failures in 2 minutes with a very high signal-to-noise ratio. And since Q3 in 2019, when we launched InfraProber, the mean time to detection for the critical instance at DoorDash was reduced by over 80%. InfraProber contributed greatly to this big win. In the future, we will keep adding more infra components to InfraProber and keep improving the alerts reliability. In the long term, InfraProber alerts will set a baseline as our infrastructure SLIs and help prioritize our infra investment. Moreover, as our infrastructure matures, we will use the health signals here as the indicators to drain traffic automatically from unhealthy regions to healthy ones, which will move our infrastructure reliability to the next level. That's all for my presentation today. Thank you for listening. And if you'd like to learn more details, we have some blog posts in the DoorDash engineering page. So next, I'll hand over to Steve to introduce how we authenticate and access to X3 securely.
Hi, everybody. I'm Steve. I work on the core infrastructure team with Shannon. I've been here a little more than a year. And today I'm going to talk about CloudFront signed URLs, which is a fairly new feature that Amazon added recently. So in our three-sided marketplace, we have to provide invoices to our merchants. And long ago, probably before we even had a portal, they needed to get the merchants their invoices. And so if we were to build this today, this is probably how you would build it, right? We'd have a merchant portal. The restaurants would log in, you'd go to your invoice history, you'd click a link, and we would generate an S3 signed URL, which the user would never see. It would be returned and you'd be immediately redirected back to fetch the file. That was really the intention of this S3 signing. So, but what happened, next slide, please. So, but what happened is, we didn't have time to build the portal or whatever. This all happened long before I started with the company, but we had to get people their invoices, and S3 seemed like the right way to go. So whoever did this way back in the day decided, hey, I can use these signed URL links and I can create years long expirations on these things and just email them to the merchants. And this is what we've been doing for years and years. But in 2018, Amazon announced they were making a change to the way these URLs were signed, and it had a 7-day maximum. And so what we were doing before was not going to fly. The team that sort of owned this had to come up with a new solution. Next slide, please. So basically what happened was just through dumb luck, Amazon had released a new feature on CloudFront, which you would normally put CloudFront in front of an S3 bucket to serve up your content. But they added these signatures so that, like you can see here at the bottom, you can run some code. Here I did with a Python script, but you would build your application to sign the actual URL and return that to the customer. And those URLs could have various various policies on it. You could say it has to come from a certain IP or it'll live this long. So it was almost a drop-in replacement for what we had been doing. So we decided this was a great short-term solution until we can actually build it into the merchant portal. Next slide. Fronting S3 buckets with CloudFront is not a new thing. This has been used for a very, very long time. It has some extra benefits over just making your buckets public. Most specifically is you don't have to use an Amazon domain. You want it to come from your company domain. You want it to be secure. You might even want to do things like allow or deny list certain countries and things like that. But too often you see people simply expose the bucket publicly. And if you look in that little access section there's sort of 3 states that buckets can generally be in. By default, it's that first one, which is objects can be public. And then down at the bottom, you've gone through and said, I want this bucket to be public and everything in it is just completely exposed. Obviously, that's not what we wanted. That middle one is really what you want, which is you do not allow any access to S3 in any way publicly. You always want to go through some sort of proxy. And here's why. Next slide, please. Too often in the news, you will read about these like data breaches or whatever in Amazon and S3. They're not actually data breaches. It's somebody misconfigured something or misused something. And so, part of the reason I wrote this blog post was because I wanted to provide a sort of very, very detailed, complete guide on how to set this up properly. Amazon has great tools, great documentation, but you have to read it all, and that takes a long time. And you have to connect all the dots. So I've connected all the dots for you. The blog post, obviously this is kind of a shameless plug, but it's really meant to be a useful resource for you, right? A complete implementation in Terraform on how to properly secure the buckets, how to do the signature checks. There's some niggly details about the formats of the keys, and those are really important. I provided a signing example program in Python that you're free to use. Even if you leave the signature checks off and it's just a properly locked bucket with a CloudFront delivery mechanism, you can do that as well. So please make use of this. Don't expose your buckets publicly. You'll have a bad day. And with that, I'm going to pass it back to Justin for the panel.
Thank you so much, Steve. Really appreciate that. And thanks to all the panelists. Lots of interesting talks here. And thanks for running up those blog posts. I hope people check those out. All right, we're going to segue now into our panel discussion. First, I want to introduce our panelists. First up is Jeannie, Bahwana, and Angela. Starting with Jeannie, can each of you take a minute to introduce yourself and tell the audience how long you've been at DoorDash, what your role is, what team you're working on, and kind of what your team is working on?
Sure thing, I'll go first. So hello everyone, my name is Jeannie. I joined DoorDash in September of 2020. So I think I'm like a year and a half years old now. Personally, I'm on the Drive team, so it's actually same team as Ben. And in case you don't know what Drive is, imagine yourself going to like Walmart.com, Chipotle.com, your favorite restaurant or grocery store.com, and creating an order. And when you select delivery, it's the choice of getting your order to you. what might happen in the background is a DoorDash dasher could be delivering your order for you. So that's what Drive's product is, like a white label logistics solution. So the merchants can focus on their experience for their shoppers, but not have to deal with the complexity of the logistics systems, because that's what DoorDash is good at. So for my team in particular, I'm on the Drive merchant experience team. So what that means is we actually provide tools for our merchants to be able to go in, like see their orders happening live, perform operations on orders like edit, cancel, and reschedule, and also create deliveries as well. So you can imagine a merchant going in, filling out a form, clicking submit, and voila, a dasher shows up at their door.
Hey, thank you, Jeannie. This is Bhavna. I am the engineering manager for experimentation platform team here at DoorDash. It's been 8 months since I joined DoorDash, and my particular team focuses on building systems via which DoorDash as a company can make decisions with rigor and accuracy. So currently we are focusing on building the A/B testing platform where all the employees can come in, test their changes, and then release their features with confidence and rigor.
Hi, everyone. My name is Angela, and I joined in April 2021, almost a year at DoorDash. I'm currently a software engineer on the logistics platform, the same team as Justin. So as Justin mentioned, the main goal of our team is to support other product teams to develop their features on the top of our fulfillment platform, and as well as like responsible for the core logistics functionality such as delivery state and the assignment progress.
All right, thanks for those intros. I'm just going to ask a few questions of each of you just to get a little bit of flavor of what it's like to work at DoorDash. Jeannie, let's start with you. What is the onboarding of a new engineering hire look like at DoorDash, and kind of what do we expect of people as they come on board?
Sure thing. So I'm gonna lay out, like imagine if you were joining DoorDash like next week or something. So day one is actually an onboarding day for engineers and non-engineers. So think about it as like HR stuff, documentation, getting used to like what your perks are and all that fun stuff. Days 2 and 3 are onboarding specifically for your cohort of fellow engineers. So there'll be like lightning talks of various orgs, as well as a full day devoted to actually getting your dev environment set up. So by the time you walk out of day 3, you'll have your environment ready to go. We actually also have exciting initiatives right now where we're developing an engineering bootcamp. Still in progress, but basically what we anticipate is new hires will be able to build a full stack app where they'll start with a Kotlin microservice backend using gRPC. Then you'll build on top of that like web client, Android client, and iOS client, depending on your team's specialty. Thereafter, you'll be handed off to your actual team, and each team will have their own special set of onboarding. I can really speak for my team, but I think most teams will pair you with an onboarding buddy, to which they will assign you your first task and onboarding program. We have a program called 30, 60, 90 days program to check in on how your progress is. General expectation is you'll be fully ramped up or like on your way to be ramped up within.
Oh, okay, great. Sorry, I think there was I got cut off there a little bit at the end, but thanks for that answer, Uni. I just want to ask you a little bit, what do you like about working at DoorDash?
Yeah, there are many things that I like working about at DoorDash, and like if I have to pick a couple of things, the top thing that comes to my mind is the people around. Like we have amazing talent, and this is the first thing that I noticed when I first joined the company 8 months ago, and it's still like the most important and the most admirable thing about the company. Everyone here knows their art thoroughly and keep pushing boundaries of possibilities. Our value of getting 1% better each day creates that environment of continuous learning, and like everyone in the company is incentivized for being learners. Secondly, DoorDash as a company is both employee focused and customer focused, which is rare to find in the industry. We work backwards from the customers, but at the same time, company's leadership takes time each week via all hands, via Ask Me Anything sessions. And then they really go to lens for understanding what employees need, answering their questions, and that leads to a lot of employee satisfaction. So I think like people around is like the most like the best thing about the company.
Great, thanks so much. And Angela, sort of in the same vein, how would you describe the work environment and culture here at DoorDash?
So when I think about DoorDash culture, I think the first things that pop into my head are the fast-paced work environment and the hyper-growth. So everyone here is biased for action, and there are always new things for people to work on. So for example, recently DoorDash made expansion into Japan, and I had the opportunities to collaborate with teammates overseas to help them solve localization issues on the back end. I think overall, there are just like tremendous amounts of opportunities for engineers to solve like very interesting problems and drive impactful work at DoorDash. So far, everyone that I work with is like extremely helpful, and everyone's like very passionate about their work. And I consistently felt challenged every day, and I am getting better at 1% every day as well. I think our core DoorDash values, such as like be an owner, bias for action, customer obsessed, etc., is what made the DoorDash successful today. And I think if you are someone who's like looking for a company to learn and grow as a software engineer, and DoorDash is a perfect place.
Great, thanks so much. So I see we're at the top of the hour, so we may have to wrap up here, but if folks want to stick around, we may hang around for 5 more minutes just to answer live questions, but I do want to say thanks everyone for attending. It's been fantastic. Some of our panelists here may have to drop off, but if folks can stay on for 5 more minutes, we might just sort of answer random questions. One question I thought was pretty interesting, and Ashwin, I don't know if you're still around. I thought this might be interesting for you since you've been working on both the monolith and the new microservices stuff for a long time. Someone asked, let's see, the question was, what challenges are you facing with the microservice architecture move, and any specific design patterns being used here? I thought that might be interesting to talk. Everyone talks about only the good stuff, but it might be interesting to talk about some of the challenges too.
Yeah, definitely. So, so first challenge I would say is probably understanding all the use cases that went into the monolith and all of the interactions, since all of that code was written a long time ago by people who were not working here anymore. It's often, that's like one of the challenges. Second challenge with microservices is definitely to now orchestrate all of those things across a fleet of services, and debugging and any sort of observability into a single request trace across all of these services suddenly gets more challenging. And we've definitely invested a lot of effort into open telemetry and more sort of like sampling based loggers, or like request sampling based logging frameworks internally to sort of counter that. Yeah, but aside from that, I'm trying to think. Nothing else that sort of stands out. The other thing is also like running operations for a service is something that every team has to sort of understand the internals of, and be an expert at. The release aspect of it, the site reliability aspect of it, understanding the whole observability story, and that can be a lot of information that most service owners will do now need to have.
Nice. I guess I'll ask a question, and anyone should feel free to jump in. I do think one of the more interesting things is the choice of language here on the back end. Kotlin is typically a language that's thought of as Android, and the adoption here seems to garner a lot of interest in that particular language. especially from folks who are coming from Java. I'm just curious, anyone should weigh in, really. I'm not going to direct this to anyone, so someone will have to speak up. But what are your impressions? I mean, for people who are really writing in it day in, day out, what do you like about it? What do you hate about it? Then I'll talk at once. Come on, Ben, I know you can do it.
Sorry, I think I'm having some internet issues. Could you please repeat what was just asked?
Oh, sure. And maybe it was my take, or Jeannie too, if you want to weigh in. Basically, my question was just to get a sense of impression from folks on the choice of Kotlin as a backend programming language. Since lots of people are interested in how that is, and particularly like comparing it versus Java.
Yep. So I think between Java and Kotlin, we get a lot of the benefits of the JVM libraries and things like that, as mentioned previously, but we get some nice syntactic sugar. So, avoiding writing lots of setters and getters, which is Java is somewhat plagued by. We get nice support for concurrency. It is a powerful language, so we have to be careful to how we're using certain language features, because there's many different ways to do things. But in general, I tend to enjoy some of the functional programming paradigms we can use, and easy use of various functions on lists and maps and things like that.
Jeannie, you want to add anything?
Sure. I feel like Ben might have worked in Kotlin way more than I have, at least recently. But I can say that coming from a Java developer background, like I've worked in Java for like a year or so, coming to Kotlin, it was like such a nice breath of fresh air, actually. And I'm mainly talking about like the syntactic sugar that or reduced boilerplate code. For example, in Kotlin, there's a concept of a data class. As soon as you write like data class my object blah, then you don't need to write the getters or setters as soon as you define the properties. So you just save like 50 lines of code if your class had like 15 fields or something like that. So that was super nice. There's also other features like extension functions too. So if you have like an integer object, you can say int.toString to my special string or something, and you just make a brand new function based off of that type, and then it's a one-line call instead of like writing 20 lines to do the same thing. So I really enjoyed that a lot.
All right, thanks so much. Thanks to all the panelists, and also thanks to the over 100 of you who stayed on a little past the top of the hour. We are going to wrap it up there. Really appreciate everyone. Take a look at those articles on our engineering blog, and let us know if you're interested in joining DoorDash. Thanks again.